This is the part 6 of a tutorial where you are designing and building this keyboard. In this video we are going to design the case, the box for our keyboard. If you haven't watched the previous parts of this tutorial, links are in the description. Let's start. Go to Place, and these are the commands what we are going to use to create our enclosure. I'm going to start with this one. Open. This can be useful window, so you can have it open. You will see immediately 3D view of your enclosure. Now go back to our project and draw the enclosure. Select it and use exactly the same numbers what I'm going to use. So this is the X and Y starting position. Use the same width and height. We can also round the corners. Now go up, use this one, layer is correct, and adjust these numbers. If you are not sure what these numbers are doing, you can play with them and you will see in your 3D view what they are doing. But I'm going to use these numbers because it is a quick way to build this enclosure. Okay, now this is the 3D view and this is what we have created. You can also use the 3D view in our PCB, but there are some commands missing, so I'm not really going to use it. I will close this one and I will use this preview. Okay, that's the individual window for a 3D view of our board, and here we can use these special commands to adjust the view. Okay, we need opening around the switches and the encoders. That's what we are going to do. So we are going to work with these 3D shell layers, and I would like to see where the encoders and buttons are, and make this rectangle. So this is going to make the opening in our enclosure. Do it like this. Okay, and again use exactly same properties what I'm using here, same dimensions and same values here. So top layer, slot depth, and let's have a look. Okay, we created the opening. This is the slot depth. You basically specify there how far you would like to go. We can make it a little bit smaller. How far you would like to go with the cut in your enclosure. This is enough because our enclosure thickness is much smaller than this cut. Okay, perfect. Now the openings around the encoders. Let's do it. Exactly same way as what we did for the switches. We are going to place this, but circle this time. Do it like this. I'm going to copy it, paste. So we have 3 of them. I'm going to place them just above the encoders. So I'm double checking the position of these encoders. Select and use the same position. Okay, do exactly the same for this one. Remember, put it here. And the last one, remember, and put it here. Okay, we don't need this anymore. We would like to round these corners so it looks nicer. And now let's have a look. Perfect. And the corners are rounded. Next, we are going to do openings for the LEDs, these LEDs. And we are going to do it a special way I'm going to explain. So we will use this transparent filament and we will place it into something like this. Okay, this is a different enclosure, but this is just to show you what we are going to create. And this is how it works. This filament is really, really good. Like, watch. You can use it to guide the light to the top of our box. So I'm going to use this. We need to create these columns where we will insert the filaments. So use exactly the same numbers and place it above the LED. We need 3 of these. And place it like this. Okay. Now, when we have a look what we created, these are the columns. And we need the holes. So place, this time we are going to place the holes and do it like this. Use exactly same numbers. We need 3 of them. Place it here. Okay. And double check what we created. Perfect. Super simple, like super simple. I'm going to double check if the position is correct. We would like to see the top shell and 3D models. And you can see the holes are exactly above the LEDs. Okay. I like it. Perfect. Next, we need the opening for the USB connector. And this is there is a special way how to draw this. So first we need this line, which will specify the bottom of the enclosure. Remember this position. And above this line, we are going to create the opening. Okay. So I will create it like this, because I would like to show you what is going to happen. Let's have a look on 3D view. See, right now the opening is not exactly where the connector is. We need to move it a little bit. Okay, we need to make it like this. Use the same numbers. How did I come up with these numbers? I just played around and measured distance of the connector, size of the connector, and that's how I come up with these numbers. But to make this tutorial quicker, I'm not showing you how exactly I where exactly I get the numbers, because it would take a long time. But I'm sure you understand how to place this rectangle. Okay, this looks good. But there is this PCB which is in collision with this enclosure here. So maybe we would like to also add some kind of opening for the PCB. So what I'm going to do, I'm going to draw another line just very close to the connector like this. Okay, do it like this. Remember the numbers, or use exactly same numbers what I have. And from this special line, we would like to create another rectangle which is exactly in the position where the PCB is. And this is important. So let's have a look. Okay, can you see where is the opening? Right now it's there. And it looks like it is deep enough for the PCB. We just need to place it into correct position. So use exactly same numbers. And good. Okay, now there is opening for the PCB, and PCB can very nicely fit, and it will not be in collision with the enclosure. Perfect. We are going to add support for screws to be able to screw the top and bottom of our box together. We are going to use this and place it here. Only place one because we would like to tweak it, and then we will copy and paste it. We would like to have it on top shell and use the same numbers what I'm using. Again, if you would like to see what these changes are doing, have a look on 3D view. Okay, so this is what we created, but this is not exactly what we want. We need to adjust these other parameters. So maybe we would like to use this stiffener, make it stronger, so it doesn't snap when you screw the screw inside, or when you screw a screw inside. And we don't need this. Okay, this is exactly what we need. Perfect. So what we can do, we can place it just above the mounting hole. And now we can copy it and place it on all the other mounting holes. Hold it in the middle and place it above the second mounting hole. Double check the position. Third. And the fourth one. Perfect. Let's have a look. Okay, this looks good. I would like to double check the position. It is just above the mounting hole, so that's really good. There is a little bit of tolerance, so there is a little bit of space between the hole or top of our PCB and the pillar, but it's fine. Okay, so these are the positions. Use exactly the same positions. Perfect. We need something similar also on the bottom enclosure. So disable top. We only would like to work with the bottom one. And use these numbers. Again, first only place one, double check if it's what we need, and then we will copy and paste it about the mounting holes. Let's have a look. We need opening for the screw, okay? And that's this setting. Watch, when I enable it, it makes this opening. Okay, change the values, use this and this. Okay. Now we are going to move it about the mounting hole. Check the position. Copy. Hold it in the middle. And paste about the mounting hole. Also here. And here. Double check. Okay. I can't see the copper from the mounting holes. Maybe I'm going to make it a little bit shorter. So I'm going to select this and make it a little bit shorter, like this maybe. Does it help? Okay, now I can see the copper. Looks okay. I'm going to use same for this other. Make it a little bit shorter so we can see if it's placed correctly. Go to enclosure. Okay. This looks good. I'm just double checking. Okay. Now, what next? There is one more thing what I would like to do. I would like to place here in the middle something, some kind of support which will help when the encoders are pressed. So just draw a circle here, place it here, and change this. Okay, oops, it's on the top, we need to move it on the bottom. Okay, double check. Okay, so basically this is just below the PCB, and it prevents bending the PCB when we will be pressing the switches on the encoders. Okay, save, lock the enclosure, Now we are going to export these 3D files. This is the file what we just created, or these are the files what we just created. I'm going to copy them into our project directory. I'm going to rename this. Just make it a little bit easier to use with my 3D printer. And I'm going to drag and drop this into software which I use with my 3D printer. And we are going to try to 3D print this enclosure just to be sure it's correct before sending the enclosure into production. Having this simple 3D printer in my office, it's super useful. If you don't have 3D printer, really consider to buy one. Very, very useful. Okay, I'm going to print these two at once. So I place both of them. A few adjustments. And let's have a look. Okay. Maybe can move it a little bit. Okay, and let's try to 3D print this. See, there is the support. You need support for these holes, but otherwise it's very simple to 3D print. Save to SD card. And this is how it looks when it is 3D printed. This is the PCB. I printed PCB on paper. A little bit later I will show you how you can do it. And it's mostly okay. I only noticed two things what we need to adjust. First one is the button. We need opening under the button, and also we would like to adjust these the pillars for these mounting holes, because there is metal plate for the switches and it is in collision. So first create the hole for the button. It's very simple. You should know how we are going to do that. Just draw a circle. Okay. Now be sure it's on bottom, and we would like to move it above the button, and that's it. Super simple. We can double check. Is there the button? Oh, is there the hole? Yeah. And it is just above the button. You can see it. Oh, see, this is the length. We don't need so big length. We can make it shorter. It's not going to make any problems, but I just like to have it correctly. And you can see it's just above the button. Perfect. This button is used when you will be updating firmware. And we need to remove these ribs around the pillars, because as I said, they are in collision with the metal plate for the switches. This is what is problem, these two. But we have to remove all 4 of them, and it's very simple. Just we just would like to work with top and disable this. Disable it also here, and double check. Okay, see? This looks good. And this is also a reason why I 3D printed the enclosure, so I could find out what everything we need and if the enclosure is correct before sending the enclosure to manufacturer in JLC. Lock this and save. Now, again, generate the outputs, and these are the outputs what we will use when we will be ordering our PCBs. You can order enclosure in JLC or JLC 3DP. So if you don't have 3D printer, don't worry. I'm going to delete the old files. These are the wrong files. And this is the new one what we generated, and I'm going to copy it into our manufacturing directory. So these are the files which we will then send to production. We can double check if these are the correct files. Yeah, you can see there is the hole, and we can double check also the pillars for the screws. Okay, this is the correct enclosure. Perfect. And I promised to show you how you can print PCB on paper. So for example, this is the top layer of our PCB. Here are the settings. I'm using color printing, so I check the background to be white and check all these other layers. Or if you would like to see more, you can check also different layers. And you can use color or black and white printing. These are the settings for the bottom, to print the bottom of our PCB. And don't forget mirror these layers, okay? If you would like to add more pages, you can use it, or you can do it this way, but I only would like to print top and bottom. Okay, and these are the top and bottom sides of our PCB. I'm going to download it. Because I would like to print this on paper. And it may be a little bit tricky to print a PCB on paper. That's why I'm going to show you how you can do it. So this is the PDF what we just created. And if you would like to print PCB on paper, be sure in your printer properties you select the correct paper size. I'm using color 3D printing. Be sure this is selected, actual size. And also here in these settings, be sure the size of the paper is correct. Very, very important. Now print. And save. This is how it looks. Top layer, bottom layer of our PCB. And you can double check the size. It needs to be exactly what is in our PCB. Double check the position of the mounting holes and the size of the board. I'm going to copy this license, and I'm going to place it also inside of our schematic. Okay. Maybe make it a little bit bigger. And I'm going to do a few more things. I'm going to add few more information inside of the schematic. So here I'm going to add some information about where to watch the tutorial and where to download the files. Here are all the 3D files, okay, which you may want to use. It's already published. When I was creating this video, it was not published yet. I was waiting until I create the final 3D models. So download all the 3D models there or on my GitHub. And these are all the other things what you need to build this keyboard. Okay. Nice. Just moving a little bit to make it nicer. And save. Check DRC. No errors. Perfect. And we are finished. You designed your own keyboard. Well done. Only what is missing, we would like to manufacture it. How? That's exactly what is in the next part of this tutorial. You will find the link in the description. And don't forget, if you would like to learn more about electronics, check out our online courses about schematic design, PCB layout, EMC, measurement. We have courses about KeyCAD, Altium Designer and more. Go to fedevel.com and have a look. Thank you very much and see you in the next video. Bye!